All right, there. Seem to have gotten this a little more figured out. So, copied my table from the previous page, and I went ahead and made myself a first quadrant of a coordinate plane so that we can go ahead and graph this. So, I labeled it with some numbers that seemed pretty easy. We have some values here that are going to make whatever graph we make difficult to get perfectly accurate, but we'll do the best that we can. So it looks like I'm starting with 1, 825. We'll put that around here. 2, 1650 is going to be about here. 3, 2475 is going to be just about 2500. 4, 3300. And 5, 4125. I'd say we did a pretty good job. Those look pretty much in a line. And now we just need to make sure that we've got them labeled correctly. Our days is our X and our Y is small cars. So there's our graph. Again, yours is on a separate sheet of paper. Your numbers that you chose might be a little bit different, but it should look something vaguely like this. Now for our last problem on the page, we're looking at multiple representations. Refer to the table on the right. Describe the pattern, if any, in the table. So let's take a look at these. We have 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Now, the numbers aren't going up by the same amount each time. They go up by 3, and then 5, and then 7, and then 9. So I guess you could say that pattern, it's kind of going up by odd numbers, consecutive odd numbers. And there's not really a clear pattern of multiplication from here one to the next. Here we're multiplying by 1, here we're multiplying by 2, by 3, by 4, by 5. But what some of you may have noticed is that what we're dealing with here is we have perfect squares. In other words, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So we're dealing with our perfect squares. They want us to write the ordered pairs. Well, that's easy enough to do. Let me make my font slightly bigger for you guys. We've got 1, 1, 2, 2, 2, 4, 3, 9, 4, 16, and 5, 25. And just for good measure, since this is a relation and this is a set, I'm going to go ahead and put them in braces just to be extra accurate. So let's go ahead and graph these ordered pairs on our coordinate plane. We've got 1, 1 would be about here. 2, 4 would be just over 3. 3, 9, one we can actually graph easily. 4, 16, and 5, 25. Now, describe the graph. How is it different from the other graphs in this lesson? Well, all the other graphs we've had in this lesson have been lines. They've gone pretty much straight. But this one, if we go to connect the dots, kind of scoops upward. So it's not exactly linear. We wouldn't call it linear. It is still a relation, because keep in mind, a relation is any set of ordered pairs. So it still meets that specification, but it isn't linear. So for my answer, I'm going to put this one has a curve to it. It is not linear. Now, yours might be in slightly different words, and I'm not saying that this is the only one answer, but that is one way of looking at it.